May 1944, Normandy, France. A British tank commander named Hobart stares at a field that will kill more of his men than German guns ever could. The ground looks solid. Firm grass, gentle slopes toward the beach. His engineers have assured him the soil composition will support 60 tons of rolling steel. Every calculation says his tanks will cross this ground in 14 minutes. Every calculation is about to be proven catastrophically wrong, because 6 feet below that innocent-looking grass lies something the engineers never accounted for, something no military manual prepared them for, something that will turn the most sophisticated fighting machines ever built into nothing more than expensive coffins, sinking slowly into French mud. This is the story of how Allied armor nearly drowned on dry land before reaching a single German position. But it's really about the moment when industrial age warfare collided with agricultural age reality, when all the engineering genius of 3 nations proved useless against simple physics that every farmer already understood, and what it reveals about the gap between theoretical planning and ground truth, between what looks possible on paper and what dirt actually does when you put 30 tons on top of it. To understand what happened in those fields, you need to understand what the Allies believed about their tanks. They believed armor was the answer to static warfare. After the horror of World War I's trenches, military doctrine had evolved around a simple premise: mobile firepower wins wars. Tanks could break through fortifications, support infantry, dominate terrain. The Churchill, the Sherman, the Cromwell, these weren't just vehicles, they were the physical manifestation of a philosophy that said, technology conquers geography. They believed French soil was just another variable to calculate, another factor to measure and overcome with proper engineering. They believed that if you could design a machine to cross rivers, climb hills, and break through concrete obstacles, surely it could handle a field. This wasn't arrogance. This was doctrine, tested in North Africa, refined in Italy, seemingly confirmed by every engagement where armor had succeeded. The planners in London had soil reports. They had geological surveys. They had weight distribution calculations that proved mathematically that their tanks would perform exactly as designed. The morning of June 6, 1944, was about to systematically dismantle every one of those beliefs, because 30 miles inland from the beaches, in the bocage country of Normandy, the ground was different. Not different in ways that showed up in surveys, different in ways that only revealed themselves under pressure. The soil here was ancient seabed, compressed over millennia into something that looked like farmland but behaved like quicksand when disturbed. Centuries of French farming had created a thin crust of stability, a delicate balance between root systems and clay and organic matter that could support a cow, a plow, a man walking. It could not support a Churchill tank. When the first armor units pushed inland from the beaches, confident in their technical superiority, confident in their calculations, the ground simply opened up beneath them, not dramatically, not all at once, just a slow, inexorable sinking as 30 tons of steel pressed through that fragile crust into the soup beneath. Imagine being inside one of those tanks. You've survived the beach. You've made it past the obstacles, past the mines, past the German positions that were supposed to stop you. You're inland, you're moving. The mission is proceeding exactly as planned, and then you feel it. Not a mechanical failure, not enemy fire. Just a subtle change in how your treads grip the earth. A slight drag, a feeling like the ground is grabbing instead of supporting. Your driver gives it more throttle. Standard response. More power equals more momentum equals overcoming resistance. But this resistance doesn't respond to power. More throttle just makes you sink faster. The nose of your tank tilts forward, incrementally then more dramatically. You're not moving forward anymore, you're moving down. Your treads are spinning, throwing mud 20 feet behind you, digging you deeper with every revolution. And the worst part, the absolute worst part, is that you can see other fields right next to yours where tanks are moving fine. The ground that's swallowing you looks exactly like the ground they're crossing successfully. There's no logic to it, no pattern you can identify and avoid, just arbitrary death by geography. Within hours of the inland push, dozens of tanks were stuck, not damaged, not destroyed. Just immobilized, their crews helpless inside steel boxes that had become stationary targets for German artillery. The bocage terrain made it worse. These weren't open plains where recovery vehicles could maneuver freely. These were small fields separated by ancient hedgerows, earthen walls centuries old, topped with dense vegetation, creating a natural fortress system that the Germans exploited brilliantly. A tank stuck in one of these enclosed fields couldn't be pulled out easily. The recovery vehicles couldn't get the angle they needed. And while engineers tried to figure out solutions, German guns found the range. The Allies were losing armor not to superior enemy technology, but to dirt, to earth, to the fundamental reality that all the engineering sophistication in the world means nothing if the ground won't hold your weight. The commanders demanded answers. How had this not been predicted? How had soil surveys missed something this catastrophic? The engineers went back to their calculations, confused because the math still said this shouldn't be happening. The weight distribution was within acceptable parameters. The ground pressure per square inch was lower than many vehicles that crossed this terrain successfully. On paper, everything worked. In reality, tanks were drowning. This is the gap between theoretical knowledge and practical wisdom. The engineers knew soil mechanics. They understood compression and load-bearing and moisture content. But they didn't know farming. They didn't understand that this specific type of clay with this specific moisture level, in this specific season, with this specific history of cultivation, behaved completely differently than their models predicted. There was a name for this kind of ground in agricultural circles. Farmers called it treacherous, not because it looked dangerous, but because it betrayed you. It promised support and then collapsed under pressure. And that's when someone remembered the farmer, not a specific farmer. The archetype. The man who actually worked this ground every day, who understood its moods and behaviors, not through calculation but through generations of experience. Somewhere in the chaos of the Normandy invasion, someone in the British command structure had the humility to ask a question that should have been asked months earlier. What do the locals use to cross this terrain? The answer was almost insulting in its simplicity. Fascines, bundles of sticks, literal bundles of sticks and branches carried on the front of vehicles, dropped into soft ground to create a temporary mat of distributed weight. Farmers had been using versions of this technique for centuries. It was so low-tech, so primitive compared to the sophistication of modern armor, that military planners had never even considered it. But it worked. It worked because it solved the actual problem rather than the theoretical problem. The actual problem wasn't that the ground couldn't support weight. The actual problem was that concentrated weight broke through the surface crust. Distribute that weight over a larger area, and the crust holds. But fascines were partial solutions, useful for occasional soft spots, but not systematic enough for military operations. You couldn't carry enough bundles to cross multiple fields. You couldn't deploy them quickly under fire, and they didn't address the larger reality that Allied armor doctrine was fundamentally incompatible with bocage terrain. The tanks themselves were the problem, specifically their treads. The width of a tank tread determines ground pressure. Narrow treads concentrate weight, wide treads distribute it. Allied tank treads had been designed for versatility, for various terrain types, optimized for speed and maneuverability rather than soft ground performance. They were adequate for most conditions. They were catastrophic for Normandy clay. Widening the treads on existing tanks was impossible. The hull design, the suspension, the drive system, everything was built around specific tread dimensions. Changing them meant redesigning the entire tank from the ground up, a process that would take years. That's when the farmer appeared, not literally a farmer, though the story gets told that way sometimes, but the idea of a farmer. The perspective of a farmer. Someone in the British Engineering Corps, someone whose name appears in some records as Percy Hobart, but might have been any of a dozen officers dealing with the same crisis. Someone had the farmer's insight. You can't change the tank, so change what the tank touches. Instead of trying to make the tank lighter or the treads wider, make the ground stronger. Not permanently, not structurally, just temporarily. Just enough for the tank to cross. The solution appeared ridiculous at first mention. Attach a plow to the front of the tank, not a military implement. An actual agricultural plow, modified, reinforced, but fundamentally a farming tool. Use it to cut trenches in front of the tank, fill those trenches with the fascines they were already carrying, and drive over your own prepared surface. The tank would essentially plow a road for itself as it moved, creating stable ground continuously rather than hoping the natural surface would hold. The objections came immediately. A plow would slow the tank down. A plow would make the tank more visible. A plow would add weight to vehicles already struggling with ground pressure issues. Die plow was agricultural equipment, not military hardware, and the image of British armour advancing across France while literally ploughing fields seemed to make a mockery of modern warfare. But the objections all shared one fatal flaw. They prioritized doctrine over results, image over function, theoretical elegance over practical success. The tanks were already slow in bocage terrain, constantly stopping to navigate hedgerows and assess ground stability. A plough wouldn't make them slower, it would make them mobile, which was infinitely faster than being stuck. Visibility didn't matter when the alternative was being a stationary target. And the weight issue was backwards. Yes, the plough added weight, but it solved the weight problem by changing the equation entirely. The first tests happened in improvised conditions, tankers and engineers working together in fields still within range of German artillery. They welded a modified agricultural plough to the front of a Churchill tank, the heaviest Allied tank, and therefore the most likely to sink. The design was crude: steel reinforcements on a wooden plough frame, attachment points that were barely more than hope and heavy bolts. It looked absurd. It looked like something a desperate mechanic had thrown together in a barn, which was essentially what it was. The tank advanced into a field that had swallowed 2 other Churchills the day before. The plough bit into the earth, cutting a trench roughly 2 feet wide and 1 foot deep. The crew dropped fascines into the trench as they moved, not even bothering to stop, just rolling the bundles off the front deck into the prepared channel. The tank's treads rolled over the filled trench. The ground held, not perfectly, not easily, but it held. The tank kept moving. It crossed the entire field, terrain that had been impassable 12 hours earlier, and reached the far hedgerow without sinking once. The reaction wasn't immediate celebration. It was something closer to confused relief, because this solution wasn't elegant. It wasn't what modern warfare was supposed to look like. These were machines designed to embody industrial power, technological supremacy, the pinnacle of mechanized warfare. And they were being saved by plows, by farming equipment, by a technique that would have been perfectly understandable to a medieval peasant. The cognitive dissonance was profound. Everything about tank doctrine, about armor theory, about the philosophy of mobile warfare, assumed that technology had transcended natural limitations. The tank was supposed to dominate terrain, not negotiate with it. The plow attachment forced a different understanding. Technology doesn't conquer nature, it adapts to nature, and sometimes the oldest solutions are old because they actually work. Within days, engineering units were fabricating plow attachments for every tank operating in bocage country. The designs evolved rapidly. The crude welded prototypes gave way to standardized mounts that could be attached and removed quickly. The plows themselves improved: stronger materials, better angles for the cutting edge, reinforced frames that could handle repeated impacts with roots and rocks. Some versions included small bulldozer blades for pushing fascines into position. Others incorporated rollers that packed the filled trenches before the tank's full weight hit them. The modifications were happening in field workshops, not factories, tankers and engineers solving problems in real time based on immediate feedback from combat conditions. This was innovation at the speed of necessity, driven by the simple reality that tanks needed to move or they needed to die, and nobody was accepting death when a solution existed. But here's what's important. The plow didn't just solve a technical problem, it forced a philosophical shift in how the Allies thought about armor doctrine. Before Normandy, tank warfare was conceptualized as the triumph of the mechanical over the natural. Tanks dominated battlefields because they transcended human limitations. Speed and protection and firepower that no infantry could match. The bocage revealed that nature hadn't been conquered, it had just been avoided. Most tank battles happened on terrain that happened to be suitable for armor. When armor entered terrain that wasn't suitable, all the technological sophistication meant nothing. The plow represented a humbling admission. We don't control the battlefield, we operate within its constraints, and success comes from understanding those constraints rather than pretending they don't exist. German response to the plowed tanks was confusion mixed with grudging respect. Intelligence reports from captured German officers reveal their bewilderment at seeing British armor basically farming its way across Normandy. To soldiers trained in a military tradition that emphasized efficiency and technical precision, the sight of tanks pulling plows seemed almost comical, an admission of Allied inferiority. But the German assessment missed the point entirely. The measure of engineering success isn't elegance, it's effectiveness. The Allied tanks were crossing ground that should have stopped them. That was the only metric that mattered. The Germans could mock the plows all they wanted. The plows were winning, because while German doctrine said tanks should dominate terrain through superior design, Allied practice now said tanks should adapt to terrain through flexible problem-solving. One approach looked more impressive on paper. The other approach actually worked in French mud. The psychological impact on the troops was significant and complicated. On one level, the plow tanks worked, and working solutions build confidence. Crews that had felt helpless watching their vehicles sink into the ground now felt capable of handling the terrain. The bocage stopped being an insurmountable obstacle and became just another tactical challenge with a known solution. But on another level, the plows were a visible reminder of vulnerability. Every tank carrying a plow was admitting, wordlessly but obviously, that it couldn't handle the ground on its own. That admission damaged the myth of armor invincibility that tank crews depended on psychologically. You want to believe your tank is a fortress, unstoppable and dominant. It's harder to maintain that belief when your survival depends on a farming tool welded to your front deck. The engineers who designed the plow attachments found themselves in an interesting position professionally. In military culture, innovation is celebrated, but only certain kinds of innovation. Breakthroughs in weapons technology, improvements in armor or firepower or speed, these earn recognition and respect. Agricultural adaptations to overcome terrain limitations, these earn results but not glory. The men who figured out the plow solution saved lives, possibly thousands of lives, definitely hundreds of tanks and their crews. But their innovation didn't fit the narrative of technological progress that military institutions prefer. So they were recognized quietly, rewarded modestly, and then mostly forgotten in the official histories that focus on dramatic battles rather than practical problem-solving. This is how expertise gets erased, not through active suppression, but through passive neglect, through the simple fact that unglamorous solutions don't make compelling stories. By late summer 1944, the Bocage campaign was over. Allied forces had pushed beyond the coastal regions into terrain that, while still challenging, didn't have the specific soil conditions that made the plows necessary. Tank doctrine began to evolve away from the agricultural adaptations, returning to conventional armor theory now that conventional armor theory was working again. The plows were removed from most tanks, stored in depots, eventually scrapped as the war moved into its final phases. The innovation that had been crucial for 2 months became irrelevant for the next 18. This is the nature of context-dependent solutions. They're brilliant when needed and forgotten when circumstances change. But the lesson shouldn't have been forgotten. Military power isn't about having the best technology. It's about having the most adaptable mindset. Think about what actually happened in Normandy's mud. The most technologically advanced military force ever assembled, equipped with the finest armor ever built, supported by unprecedented industrial capacity and engineering expertise, was stopped by dirt. Not exotic terrain, not extreme conditions. Just regular agricultural soil that happened to be wet and happened to have the wrong clay composition. And the solution didn't come from more technology, it came from less. It came from looking at how farmers solved the same problem with tools that hadn't fundamentally changed in centuries. This should have been humbling. This should have prompted a complete re-evaluation of how military planning incorporates environmental factors and local knowledge. Instead, it was treated as an anomaly, a unique situation that required a temporary fix, not a revelation about fundamental gaps in doctrine. The records from the period show fascinating tensions between different kinds of knowledge. You have military engineers, trained at the finest technical schools, fluent in mathematics and materials science, confident in their models and calculations. And you have agricultural specialists, often called in as consultants, whose education came from working soil and whose expertise was observational rather than theoretical. When these two groups interacted, there was consistent friction. The engineers wanted to understand why the ground behaved the way it did, to derive principles they could apply systematically. The farmers just knew what worked, accumulated wisdom that didn't always have clear explanations, but had the virtue of being correct. The military mind prefers the engineer's approach. Knowledge should be systematized, testable, reducible to formulas. But the bocage didn't care about preferences. The bocage rewarded whoever solved the problem, regardless of whether their solution fit institutional prejudices about what knowledge looks like. Some historians argue that the plow innovation delayed the breakout from Normandy by making the Allies too comfortable with slow, methodical advances through difficult terrain. If the tanks had remained unable to handle the bocage, the argument goes, commanders would have been forced to develop more creative tactical approaches, perhaps finding routes around the difficult terrain rather than grinding through it. This counterfactual is impossible to prove but interesting to consider. Did the plow solution actually solve the problem, or did it just make an inefficient approach temporarily viable? Could the campaign have proceeded faster with different tactics instead of modified equipment? The question reveals how we evaluate innovations. We tend to judge them by whether they work, not by whether they're optimal. The plows worked, therefore they're remembered as successful. But working isn't the same as being the best possible answer. There's an irony that the British military, fighting a modern mechanized war, was saved by agricultural wisdom that its society had been systematically devaluing for a generation. Britain in the 1940s was deep into industrialization, with farming increasingly seen as a backwards occupation for people who couldn't adapt to modern economic life. The cultural prestige was all in factories, technology, urban sophistication. Rural knowledge was dismissed as primitive, irrelevant to a world being reshaped by machines and science. And then those machines got stuck in mud, and the primitive rural knowledge turned out to be the only thing that mattered. This pattern repeats throughout history. Societies develop complex technological systems, come to believe those systems have transcended natural constraints, and then discover, usually at the worst possible moment, that nature hasn't changed and the old wisdom was wisdom for good reasons. By the time the war ended, the plow attachments had been removed from nearly all Allied tanks. The bocage campaign became a footnote, interesting to specialists, but not part of the main narrative about armor warfare in World War II. The tanks themselves, the Shermans and Churchills and Cromwells, remained symbols of technological achievement and industrial capacity. Their temporary dependence on agricultural equipment was quietly erased from the story, not through conspiracy, but through the natural process by which institutions remember their successes in ways that reinforce preferred narratives. Military culture wants to celebrate technological superiority. It doesn't want to dwell on moments when technology failed and pre-industrial solutions saved the day. So those moments get minimized, treated as aberrations rather than insights. But the farmers knew. In the years after the war, in the cafes and fields of Normandy, there were countless conversations where locals explained to visitors exactly why the Allied tanks had struggled, with the patient tone of people describing something obvious to anyone who actually worked the land. They knew those fields were treacherous. They'd always been treacherous. Any farmer in the region could have told military planners that heavy vehicles needed special consideration in bocage country. But nobody asked the farmers. The planners looked at soil surveys and engineering reports and felt confident in their technical understanding. The actual people who crossed that ground every day, whose livelihoods depended on understanding its behavior, were never consulted. This is the cost of credentialism, the assumption that formal expertise is always superior to practical experience. Sometimes it is. Sometimes the engineer knows more than the farmer. But sometimes the farmer knows exactly what the engineer is missing, and the only way to find out which situation you're in is to ask. There's a broader lesson here about how organizations handle problems that don't fit their existing frameworks. The Allied command structure was brilliant at logistics, at coordinating massive forces across multiple theaters, at supplying millions of men with food and ammunition and equipment. But it struggled with bocage mud because mud wasn't a logistics problem. It was a geography problem that required local knowledge and practical adaptation rather than systematic planning. Organizations optimize for the kinds of problems they expect. When unexpected problems arrive, especially problems that require different types of expertise or different approaches to knowledge, institutions often fail not because they're incompetent, but because their very structure makes certain solutions invisible. The Plow innovation came from the edges of the system, from officers and engineers working in field conditions who were close enough to the problem to see beyond doctrinal assumptions. If the solution had needed approval from higher command before implementation, it might never have happened. The German experience with bocage terrain was different but equally instructive. German tanks had similar ground pressure issues, but German doctrine emphasized defensive operations where mobility was less critical. A tank in a prepared position doesn't need to cross soft ground. It just needs to hold its position and kill anything that tries to cross. The Allies had to solve the mud problem because Allied doctrine required offensive movement. The Germans could work around it because their tactical situation was different. This reveals something important about how context shapes innovation. The Germans didn't develop plow attachments, not because they were less innovative, but because their situation didn't create the same pressure to innovate in that specific direction. Innovation happens at the intersection of need and possibility. Remove either element and the innovation doesn't occur, regardless of how clever the potential innovators might be. Think about the tank commander from our opening, watching his vehicle sink into Norman soil. That moment of helplessness, of understanding that all his training and all his equipment meant nothing against simple physics, that's a moment of forced humility that every expertise eventually faces. You can be the best tank commander in the British Army. You can understand your vehicle completely, know its capabilities and limitations, have perfect technical knowledge of how every system functions. And none of that matters if you don't understand dirt. The ground doesn't care about your expertise. It doesn't yield to credentials or confidence. It just does what ground does under pressure. And if your knowledge doesn't include that reality, then your knowledge is incomplete in ways that can kill you. The farmers who watched Allied tanks struggling through their fields must have felt a complex mixture of emotions. Sympathy, certainly, because they were watching men risk their lives to liberate France, but also maybe a certain vindication. These powerful foreigners with their incredible machines and their scientific confidence had arrived with such certainty, such assurance, that their technology could handle anything, and the land had humbled them. Not maliciously. The dirt wasn't taking sides, it was just being dirt. But there's something profound about watching expertise meet its limits, about seeing the moment when all the education and resources and institutional backing in the world can't substitute for the simple knowledge of how things actually work in actual conditions. The engineers who developed the Plow solution were performing a kind of translation. They were taking agricultural wisdom and converting it into military application, finding the overlap between farming knowledge and armor doctrine. This translation required humility, the willingness to learn from a domain they'd been trained to see as inferior. It also required creativity, because you couldn't just bolt a farm plow onto a tank and call it solved. The original plows weren't designed for that application. They needed reinforcement, modification, integration with the tank's existing systems. The innovation wasn't in the plow itself. The innovation was in recognizing that farming had already solved the problem and then adapting that solution to a different context. This is often how real innovation works. Not creating something from nothing, but recognizing that the answer already exists somewhere else and having the flexibility to borrow it. When you look at photographs from the Normandy campaign, the images of tanks with plow attachments are striking because they look wrong. The aesthetic of military hardware emphasizes sleek functionality, everything purposeful and integrated. The plows look tacked on, improvised, temporary. They break the visual logic of how weapons are supposed to appear. But that wrongness is what made them right. They worked precisely because they weren't trying to fit military design philosophy. They were solving a specific problem with the most direct approach available, and if that approach looked ridiculous, well, looking ridiculous while advancing is infinitely preferable to looking impressive while stuck. The story of the bocage plows is usually told as a triumph of Allied adaptability proof that democratic armies can out-innovate authoritarian ones because they allow more flexibility and individual initiative. There's truth to that interpretation. The Plow solution did come from decentralized problem-solving rather than central planning. But the story is also about the limits of institutional knowledge, about how expertise can create blindness, about the dangers of letting confidence in your models prevent you from checking those models against reality. The Allies weren't humble in Normandy. They were forced into humility by circumstances that revealed gaps in their understanding. That's different from choosing humility as a value. It's the humility of having no other option, which is better than no humility at all, but not exactly admirable. If there's a universal truth in this story, it's this. Knowledge comes in many forms, and the most sophisticated form isn't always the most useful. You can understand soil mechanics at a theoretical level, derive equations for load-bearing capacity and compression dynamics, model how different materials respond to stress. That knowledge is real and valuable. But it's not complete. The farmer who can look at a field and tell you whether it'll hold a wagon, who developed that skill through decades of observation and experience, possesses knowledge that complements theory. Ideally, you want both. You want the engineer who can calculate and the farmer who can see. But when you can only have one, when circumstances force you to choose between theoretical understanding and practical wisdom, the evidence from Normandy suggests you should choose the farmer. Not because theory is worthless, but because theory that doesn't account for practical reality is just elaborate speculation. The tanks that crossed Norman fields with plows attached were carrying more than farming equipment. They were carrying an admission that maybe, possibly, the people who worked the land knew something important that the people who planned the war had missed. That admission wasn't comfortable. It contradicted institutional hierarchies, challenged assumptions about whose knowledge matters, suggested that education and credentials and official expertise might sometimes be less valuable than simple experience. Every tank with a plow was a mobile acknowledgement of epistemological humility, a moving reminder that certainty without verification is just arrogance waiting to be corrected. The men inside those tanks probably didn't think about it in those terms. They just knew the plows worked. But working solutions always carry implications beyond their immediate function. They reveal what wasn't working before, and therefore what was wrong in the thinking that produced the failure. Looking back across 8 decades, the Bocage campaign feels like it should have taught military institutions to value local knowledge, to consult with people who actually live in and work on the terrain where operations will occur, to maintain humility about the limits of technical expertise. Some of those lessons were learned. Modern militaries do more environmental assessment, more consultation with local populations, more recognition that cultural and geographical knowledge matters. But the lesson keeps needing to be relearned because the organizational incentives haven't changed. Institutions still reward technical sophistication over practical wisdom. Military culture still celebrates technological solutions over adaptive problem-solving. And every few decades, in some new theater with some new terrain, forces equipped with the finest technology encounter conditions their models didn't predict. And someone has to reinvent the humility of asking locals what they already know. The plow wasn't a ridiculous idea. That's the final insight worth holding. It seemed ridiculous only if you assumed that modern warfare had transcended agricultural reality, that tanks were too sophisticated to need farming tools, that military expertise automatically superseded rural knowledge. Drop those assumptions. Look at the actual problem without doctrinal blinders, and the plow becomes obvious. Obvious solutions often look ridiculous before they're proven and inevitable afterward. The distance between ridiculous and obvious is just the gap between theory and results, between what you think should work and what actually does work when reality gets a vote. In Normandy's mud, reality voted for the plow. Everything else was just commentary by people who didn't want to accept what the vote revealed about their understanding of war, terrain, and the stubborn fact that physics doesn't care about doctrine.